Hello everyone, welcome to my channel. Today we will be solving car pooling problem. Problem statement is given: you are driving a vehicle that has capacity, empty seats initially available for passengers. The vehicle only drives east such that it cannot turn around and drive west. Given a list of trips, trip equals to number of passengers, start location, end location. Contains information about the ith trip, the number of passengers that must be picked up, and the locations to pick them up and drop them off. The locations are given as the number of kilometers due east from your vehicle's initial location. Return true if and only if it is possible to pick up and drop off all the passengers for all the given trips. Few examples are given to understand the problem statement clearly. So I'll take the reference of the last example. So here we have 3 trips and the capacity is 11. So our vehicle starts from 0 and it always moves to the right direction, moves to east. So here we have the trip 1, it starts from 2 and ends at 7. So here is our trip 1 starting from 2 to 7, and for trip 2 it's starting from 7 and ending at 9. So our trip 2 7 to 9, and the third trip starting from 3 ending at 9. So starting from 3 and ending at 9. Okay, so initially all seats are available, so that means our available is 11. So what we'll do, we'll start from 0 and we'll move to the right direction. Whenever we find any trip, so we'll check the number of passengers to pick up with the number of available seats. So in this case 3 is less than equals to 11, that means we can include them to the current trip. If it's greater than the available seats, that means it's not possible to complete the trip, will return false here. So we can include T1, we'll include the T1 in the current trip. Now we'll decrement the available seats. So 11 minus 3, so it's 11. Now again we'll move to the right. So now at 3 we have another trip. So again we'll check the number of passengers to pick up. So here it's 8, 8 less than equals to 8. So we'll include them to the current trip and we'll decrement the value. So now available is 8 minus 8, it's 0. Now again we'll move to the right, and when it comes to 7, so here, so before checking that condition, we'll also verify the status of the previous ongoing trips. So here you can see the T1 is completed, so we can remove T1 from the list. So we'll remove T1 from the list and we'll increment that value. Okay, increment the available seats. So T1, in the T1 trip there are 3 passengers, so we'll increment the available by 3. T3 is it completed? No, T3 is still in progress. So now we'll check the number of passengers to pick up. It's 3, 3 less than equals to 3, yes, it's true. So we'll include T3 into the current trip and we'll decrement the available seats. So here you can see we are able to pick up and drop off all the passengers. So in this case we'll return true. So here you can observe one thing. So we are picking them up by their start location. So first of all, so we have to sort the trips by start location, and also before adding to the current trip we are checking the status of the previous ongoing trips. To efficiently check the status of the previous ongoing trips, we can do, we can store these ongoing trips into a mean heap, so based on their end location, right? So we can efficiently, so let's write down the code in Java. So first we have to sort the item based on their start location. So we'll sort the array based on start location. So t1 minus t21. Okay, now we have to efficiently query the ongoing trips, so we'll use priority queue. So we'll store in the priority queue, so based on their end location. So it's return an object, so you have to cast them to an array. Okay, now we'll iterate over all the trips. And here we'll declare one variable available. To the initially all seats are available. So here we'll check the whether the previous ongoing trips are completed or not. So if the priority queue size is greater than 0, and so we'll check the top item. If its end location is less than or equals to current trip start location, so that means we can that trip is completed. So we'll increment the available and we'll remove it from the top. Okay, once it's done, so we'll add the current trip, the priority queue. So okay, before adding, so we have to check if the available seats if the number of passengers in current trip, if it's greater than the number of available seats, that means it's not possible to complete the trip. So in this case we'll return false. Otherwise we'll add to the priority queue, and we also decrement the available seats. If we're able to if it comes here, that means we're able to complete the trip successfully. So in that case we'll return true. So let's run it. Available. Okay, now let's submit it. Okay, so our solution is accepted. So now you can see we are here. That's it for today. Thanks for watching. If you have any comments or feedback, just let me know in the comment section below.